So, hi, welcome to the 8th session of the OpenMusic Study Group. We're here this is going to be just an informal talk about different patches we have. So we're going to just see where this takes us then. If no one wants, I'll sort of share my screen and we can, I'll show you something that I've been looking at. So there was a piece for Baroque flute that I'm working on at the minute, and I wanted to do something with Perlin Noise. So does anyone know what Perlin Noise is?
No.
No.
So it's kind of like random numbers. It's based off I think it was it's an algorithm for kind of generating something that looks slightly organic, kind of. So this this might mean more to you, Frank. So I here we got some C++. So it's just for all intents and purposes, it's kind of random numbers, but it's not really random. It's kind of patterned randomness. So it was used for, I think, in the Tron, like the original Tron movie, for rendering shaders, I think, or something that looks organic but's not organic. So I thought, what's a good way of getting that random Perlin noise generator? So I went onto GitHub and stole this. And this is literally just someone's kind enough to write Perlin.Lisp. And one of the best things about OpenMusic is that you can you kind of throw these things in and it'll work. This might help Frank. Just we'll touch on a little bit of the kind of the coding side of things. Yoshi, are you kind of interested in kind of coding stuff, or is there? You're happy?
Well, yeah, please. Yeah, I mean, in fact, I've been doing quite a few of them myself.
Yeah.
So yeah, please. Yeah, but yeah,
Okay.
I'm very curious to see how you.
If you want to jump in and do stuff, and just, I mean, so if one of the things in the Lisp listener, this is our kind of REPL for Lisp code, really. So at the top, we can see, we can put in like a number and it will return. We can put in strings, floating point numbers. Doesn't want, you can't put in symbols, but you can put in key names, and we can also define our own functions. So if we look, we can, oh, it didn't close that parentheses. So we've now got a function called hello, and if we run it, you can see here we also get our output. But because it's kind of, OpenMusic has this kind of like a little, it's almost like a web. It's all everything's kind of connected. So our actual like patch is linked up to this. So I can now just write my function, which will just appear and evaluate. So the way I did brought in the Perlin.Lisp file was to put it into my own like library type of thing. So if we look here, we can just see this is the Perlin Noise code that we just saw earlier, but I've just put it in my own little file and given it the here given it the method that OpenMusic wants, so it can appear and give it a a nice picture, and then even give it some documentation. But once it's in, then I could just use it like a normal function. So what I've done here is just really looked through getting different numbers. So it's, did I call Perlin Noise? Oh, yeah. So you can see with the sort of default settings, these are kind of the Perlin numbers that we get. So we've got our X, Y, frequency, and depth, I think. And that's what's going in here. And these are the things that I decided to adjust. I decided just to adjust the X, frequency, and the depth, just to generate a lot of random numbers, really. So this is us kind of passing through almost like a graph and just kind of picking out points as a kind of pattern. I decided to kind of use some kind of basically kind of 12-tone type of transformations, reversing, getting this P1 of the patterns. And I built this little thing that takes the ones and zeros, which is just a lot of nested if statements. If we look inside, it's either going to be 1 or 0. I can get the original, inverted, reverse, rotate it at a certain, I think I've set it to a random position, so it's going to rotate. Oh no, I've actually got it to call the position. Oh no, it is random. So by changing these to either 1s or 0, I can get sort of longer or shorter patterns. So there we can see our numbers changing. Our patterns that go in that then get evaluated by the loop, which is just going to take each element and make a Perlin number out of it. So if I take this, keep those frequency and depth the same, it'll think about it. And then there we can see is my list of kind of Perlin numbers. So from that, I then bring these all kind of together with just because it's Baroque flute. I decided to not make it too complicated and make it either going to be major or minor, and then sort of just had the key set in there, and that became the kind of note reservoirs that I would draw from based off the Perlin numbers. So that's me kind of marrying the Perlin numbers to the selection of notes, and that's where we then see if this thinks about it. We get the first list, which is obviously a list of MIDI cents. So if I go to my chord sequence and just throw it into that, we can see if it has a wee think. Yeah. And there's our list of notes. And then the next one was me. I just put it into sort of used them as those Perlin Noise numbers as durational values. I just multiplied it by 1,000 and brought it all into kind of a sensible kind of number territory, and that's what the second outlet is putting out. You can sort of see here the kind of these smaller numbers in terms, well, you know, under 1,000 are going to be durational values then in milliseconds. This was then used. I just used this kind of quantize little bit to, so I can make the notes either longer. You know, if I wanted, if I didn't sort of wanted to make things last a bit longer, make the phrase a bit more just longer, then I could just times it by 2, so everything got twice as long, or you know, one's just the original, or I could make it faster by, you know, bringing in just smaller numbers. You can sort of see here everything gets a little more grouped together, and then really bringing those all together into a chord sequence object gives you the final result of. Did you hear that all right?
Mm-hmm. Mm-hmm.
I wasn't sure whether my connections were all set up there. So that's just an example of just kind of one of the things you can do with that. But once this is kind of all set up, you know, the notes that I'm drawing from are obviously quite small. But if I was to, you know, make this sort of give it a lot more to kind of draw from. I think that's, yeah. You know, then we can maybe end up with something a little funkier. It's going to be, but it'll still have that kind of, Perlin Noise is still going to have that pattern. So you can sort of see it's still a kind of, this kind of wavy pattern that's very distinctive of kind of Perlin Noise. So if I go to, oh, well, let's give it a different noise rather than just get flute. Let's give it piano. Sorry, let me just. This is just for me to not have to listen to horrible flute playback. So I think it's, if I just give it those 3. So that's the idea with that, of just getting using the kind of Perlin Noise to kind of select the pitches and also be the durational values, and sort of bring it all together. So is that does that make any sense, or is there anything you want me to?
I have a question actually.
Yeah.
On the near, it says frequency. That's what I believe that it is. The 5.5. What does that mean? Like, it's not real frequency, is it? Because if it were
No,
like a
it's like the frequency. No, yeah. It's like the frequency of that's being graphed in the Perlin noise.
Okay, yeah, sure.
So maybe if I just bring up my thing. Actually, it would be better if I use the loop. Because really, this is just me abstracting a lot of the information to fit a musical context. Perlin noise is used to generate kind of I think shader things to be used in mapping onto kind of 3D objects, so they kind of look like a tree bark. That kind of it's not random, but it's kind of an ordered randomness nearly.
Sure.
So if I kind of show it's just by kind of changing these numbers that you kind of get you kind of giving them different parameters. And I need to I don't want to say the wrong thing, because I need to go and look and delve into the documentation again to be like, oh, here's the exact kind of parameter that this means, but or how that's working on our X and Y. I'm sure there's I'm sure there's better videos explaining it. I think if you look up Perlin noise, if you kind of go down that rabbit hole, you kind of be able to unpack what's happening here. I can't remember, and I don't want to say the wrong thing. But it's in terms of graphing and plots points on a graph, it's kind of the frequency and the depth and the X and the Y are the things that I've got control over. And that's what I've been then it's kind of then the question is like, what do you then do with these numbers? How can I use these to be, I mean, the way I've done it's probably quite simplistic with the durational values, where I've just multiplied them and made them not floats. I've just kind of got the absolute values and made them milliseconds. But this then is me mapping it onto the list of positions that are fed in. They come from this. And we can kind of see this is kind of a little bit like graphing out the output, really. I mean, it's based off because this pattern that kind of goes in, that the points that I pick are kind of altered in a way. I mean, these numbers could be any numbers, it doesn't, or they could be one number. And it's just that I've found this quite interesting. We get the patterns, but the because I'm dealing with the patterns in quite a musical way, these invert retrograde things, those patterns will kind of come out here as well.
Not Peter
A. Frank, have you got any questions? Is there there must be a little bit of a C++ E crossover for you in somewhere along the line?
Yes. Well, I mean, I'm looking quite interested at what you're doing there, it's yeah. I mean, I do understand. I mean, it basically it creates random undulations onto an existing pattern.
Yes.
And basically makes the pattern more, well, it adds pieces to the pattern to create a more interesting variation of a sequence. That's what I understand out of it. Yeah.
Yeah. I mean, this is a kind of the pattern coming in is just altered in a way that makes, for me, musical sense by being by kind of tying it to these 12-tone technique, really. But instead of
the only
applying
thing
it to
is the numbers that
yes,
the list of numbers that is input on the last inlet into pattern selector. What is that list?
This
is the actual
X value. This is in terms of the graph. So if we imagine a kind of the graph of that are going to be the Perlin notes. This is our X axis.
Oh, this is the
So
X axis.
Yes.
So
this is the X axis that we're going to read. What Perlin along the the graph Perlin numbers. This is the x-axis of where we're reading.
Okay.
And from that, then it's those patterns then get fed into the Perlin noise loop, which then make them Perlin numbers. But it's in terms of the kind of I mean the actual code for the Perlin noise is all here, and you sort of see all the kind of the hash tables, and this is all the math that happens that makes it a Perlin number. That I'm just stealing. But it's just it's just a quick example. I mean, there's this is just the most recent thing that I was kind of experimenting with. There's a really good YouTube channel called The Coding Train. It's run by a guy called Daniel Schiffman, and it's a really interesting. He delves into a lot of concepts for coding. He's working on JavaScript, but obviously, like all coding languages, they kind of feed into each other. I mean, JavaScript, it's not a well, it's very different. Really, to be honest, there's no other language like Lisp, and it's I think it's just getting your head around the parentheses, especially if you're wanting to do to really kind of unlock the potential of OpenMusic. Is when you writing your own little lambda functions inside that you can just fire off quickly. So it's just like a loop that I just
it is always a question. It is always a question when you have a problem. Because I'm from a C++, come from the C++ background, I'm always so inclined to just write a function rather than actually dragging icons on the screen.
Then this is be perfect for you, because that's your, I mean, with this, that's just your function that you're just like, because to be honest, they have this for loops, and you have your sort of your while loops on lip, but sometimes I did a video on this. I think the last session was where I literally just looked at
Yes.
all, like, you know, here's the loops you can kind of do.
Yes.
But
Yes.
really,
Yes,
you know, you
yes.
could have loops here that don't have inputs that will, you know, output numbers, or you can have multi-clause and lots of nested loops. You know, it really gets within the kind of Lisp, that sort of writing a little lambda function can be incredibly, as you say, you can be very lazy. You can just go, I could try and find this thing. And especially sometimes OpenMusic doesn't like to add the functions when you click on them right away.
Yes.
You
Yes.
can get a bit
Yes,
frustrated.
yes, yeah.
But it's I mean, really, once you've that's kind of the hardest bit of this, is working out what's happening here. I mean, it is it's not too hard to kind of, once you've got there's Practical Common List is a really good book to kind of to read, to get through.
Yeah, I've been
just
looking
the very
at it, and
basics
Land of Lisp.
Land of Lisp is fantastic. I mean, the in terms, I mean, there is everything that you can do in the code, you should be able to do in the kind of graphical interface,
Yes.
including recursion. I haven't
I
worked
found
out how to do
recursion
recursion
difficult
yet.
in the graphic environment. I found that very difficult. How do you make a patch call itself?
Yes, I mean, I was trying. I have been trying to work at that for a while. Where there is a way of, then, you know, you make a patch, and then you can then drag the patch into itself. You know, so that there's something there, where you can then do some recursion. But to be honest, I've just been writing Lambda functions because it's a lot easier. You can just go while x is less than whatever, and then call itself. Because sometimes that is just easier. But that's not as, you know, it doesn't look as nice, you know.
How do you write a Lambda function that calls itself? I couldn't figure that out yet. For example, you have a little function.
Yeah. So one of the ways, this is looking more promising. Yeah, here we go. We've got a chapter on recursion. I think this is, yeah, Martin and the Dragon. So the best way is to look up, there we have our little recursion function. So, I mean, it really is, obviously, we don't need to define it as anything, because a Lisp Lambda function is basically a function without a name. So here we have x, and then really I just follow along. So we can have our count macro that will just run through p x. Oh no, because I have to call it self then.
Yes, that is
That's
the problem
it.
that I ran across. How do I call a function that has no name?
So that's it. How did I do this? Oh, I think I just made my own function. So
Yes,
it's even easier because
define a function and yes.
all you
yes,
I think you literally can copy and paste it
Yeah,
into this and it will work.
Mhm.
And then any hot p, there we go.
Mhm.
So now we can give it yes, and it will return true because we've got some odd numbers in there. 4, 6, 8. No. Yeah, just I think it's to do this kind of thing. Yeah, you need to, it has to have a name to be called. So you just got to write it yourself. I mean, in the OM listener, you know, you can have the I can't remember which one is it. This, I think it's this one, the evaluation where you can then type in functions, and I always turn that on because I always think it's very handy. But I mean, the one really interesting thing in have you checked out OM Sharp?
No, I haven't.
It's quite
I was concentrating on OM.
Yeah. It's quite interesting. I'm still getting used to what it does. It's very similar. It's much of a muchness, really. But there's one very interesting thing is that we'll show you the Lisp code for what you're typing. So if I put in my plus and I, 10, 200, let's say, and if I string my string these things together to then print out. If we take a look at our, it's not going to do it now for me. It will actually show you here. Yeah, if you click on it, it doesn't want to show us print for some reason, but it will actually show you the Lisp code that we just typed. So I just go over to my my OpenMusic. Where was I? And so in the green is the thing we want to evaluate. So if I put in the code that I just copied, oh, that's not, hasn't copied over. Copy code. Is this something they don't want us to do? There it is. So you can see this will just be exactly what I had before and evaluate to that. And if I see here with our other list, we get the same thing. So we can actually, this is quite a good way of, if you're not 100% sure on Lisp code or where things are supposed to be, but you know how to patch it. This is just something that tickled me at the minute when I first opened it up. I realized you could then really, once you've got this, then you could delete that and and then write your own Lisp function. So you can see, so you could write the whole thing. You could write an entire patch using Lambda functions and different things. Yoshi, have you used OM Sharp yet, or have you?
I'll be actually right back, but I've used a little bit of it. Yeah, but I'll be right back in a sec.
Oh, sure.
Thanks. Sorry.
Just, are you there?
Hi, Alan.
Hey.
Hi.
I was going to ask, do you have any patches you want to show, or are you?
No, actually, I was
not
sure if I was going to make it today, and I can't stay the whole time.
Oh, that's fine.
But for next time, I'll be back. I just wanted to say hi mainly.
Oh, good. Okay.
And I'm gonna follow for a while, but I didn't prepare
anything
for. I didn't prepare anything for today.
Sure. Frank,
and I haven't used OM Sharp like only 2 times. Sorry.
Yeah, no, I'm slowly kind of getting my head around kind of. I mean, it's very much it's almost like it's OpenMusic, but with a kind of a much more jazzy interface. You know, it's got it looks a bit more sleek, but I don't know whether that's a good thing. So sometimes it's nice to have the kind of the old, very pixely OM music.
As far as I understood, they are trying to make it make it a little bit more reactive. I think a little bit in the direction of Max MSP. But the last time I used it, it was in developmental stage, and many of the basic functions were out. So I thought I'm gonna wait, and then I didn't check it afterwards.
Yeah, I think in January they released the kind of first
cool.
the release, really, the 1.0. I think in January, and I think it's interesting. I mean, there's some new features, and it does seem to be more along the lines of, as you say, it is very kind of like Max MSP aesthetic, or not Max MSP anymore, Max aesthetic. I think it's interesting. I think it's kind of strange that there's been it seems to have split. You know, the OpenMusic is going one way, and then we've got OM Sharp. So I don't know. I think it'd be interesting to sort of see how that plays out in a year or two.
Yeah,
maybe they'll just,
because I think this was kind of one of the last projects of Jean Bresson. So I don't really know what's going to happen, and I must say I am right now. I'm diving into Mozlib by Julien Vincenot. You have seen this?
No, what's that?
I'll
send a link in the
yeah. I'm on my phone. I'll see whether I'll post it in the OpenMusic Facebook group.
In the Facebook, perfect.
It's actually it's the concept is very simple, but it's really nice, and it's a bridge between OpenMusic and the Max MSP world, in the sense that it's just a shell for Lisp.
Right.
And so it understands any Lisp music dialect from the major things that have happened throughout the last years. So it supports common music, it supports OpenMusic, and a bit of Scheme, I think.
Okay, that sounds interesting.
And PWGL. And so the idea is that everything becomes available in Max without having to reprogram it. So you can actually enter just straight Lisp codes in a text file, send it through the shellbox, and the result comes out like you would be using OpenMusic within MaxMSP, and it's really well done.
That's interesting. I mean, for me, it's. I mean, the one thing I always think of when people use OpenMusic, I think they sometimes forget that it's for kind of score generation. You know, it's kind of synthesizing a score, whereas Max is synthesizing sound. You know, it's and they both have very different pulls and strengths. So that, and you know, that's for me. I think sometimes people want OpenMusic to do something that it can't do.
That's not meant to.
It's just not gonna. Whereas, you know, and I think people are starting to realize how ridiculously powerful Lisp is as a programming language, and really how it can be used in many different ways. But it's when you go into OpenMusic, you've got to sort of think almost like a composer, like you know, I'm generating music that's going to look a certain way, or because by using these various things, and sort of, you know, it's thinking about your compositional process and then having that be reflected in the score. Whereas Max is you're almost like shaping sound, and you're playing about with all the fun noises and patching things. And
I think it was the original idea, at least for the Mozlib library, was mostly to preserve the OpenGL PWGL environment, which is, I think, completely dead by now. It still is downloadable, but it doesn't run anymore on I think, at least not on Sierra, let alone on Catalina Mac, and Windows. I've no idea. But there have been many interesting functions like constraint programming and a lot of rhythmic functions from Fernio and from what's his name, the Finnish Magnus Lindberg, that used to exist and used to be freely available throughout PWGL. And so Julien has tried to preserve that, and since the Bach library in Max is now perfect for displaying notes, it's the same like the voice object and the roll object and the chord object in OpenMusic. So I think he just thought, if I bring it all to the Bach library, then we can just use every possible. So all the OpenMusic functions are in Mozlib as well.
Yeah, that's interesting. I'll have to definitely put some links to that in the Facebook, because I'll be really interested to see.
I would check it out if you have Max at least, and I would really check it out, because it's if you're fluent in Lisp, you can really do very interesting stuff. Anyway, I'll let you continue.
No, that's great. I mean, this is an informal chat. It's all about kind of, this is how you discover these things. You know, you kind of go off on tangents, and then learn about the weird and wonderful things that other people are doing. And yeah, I agree with Franco. The price of Max is heavy, but they've got you. I mean, I've got the worst side of all, because I do a lot of stuff in Adobe Illustrator, so they are the mafia when it comes to payments and microtransactions and things like that. It's they just got you. Does anyone have any other patches they'd like to show? Just to kind of, it doesn't need to be finished patches, just whatever you're working on.
I had a small question.
It's always an interesting debate.
I had a small question.
Yeah,
does anyone know whether there exists a library so to take a handwritten curve and to convert it into a vectorial line so you can sample it with a BPF?
Do you know, I think in Pixels there's a way of I'd have to double check.
That's a library, Alan, or
yeah. Let me see. Let me just bring where'd I have it? I was experimenting with it a while ago. Is it this one? No. Yeah. There's I haven't used this in a while. It's gonna, I think there's so just jumping in here, there was a discussion briefly about using the picture objects to try and get some information to draw from one of these picture objects. I wasn't able to find anything at the time of recording the video, but after a little bit of experimentation, I found something that might be useful. So as we see in this, the third outlet is a list of vectorial graphics, which I think during Yoshi's patch, we saw him use a BPC to then get a X and Y axis to get the X and Y axes from the BPC, and then running those into a chord sequence to give a kind of graphical representation. In the picture boxes, I've managed to get somewhere with it. As we can see, tends to print out the object upside down. I'm not sure why that is. The patch itself is taking the X and Y from a function which turns the graphics into a list. So I can show you. So what we have that comes out of the first or third inlet is a list in which a graphic object instance is there. So if we get the car of that list, we just get the graphic object, which if we put into our graphics object to list, gives us a X and Y in a list form, which I then just loop through to then put into our X and Y axes for interface here. When you first put it in, this is what you get really, and it's quite hard. It's only when we actually look at the numbers that we're dealing with that we can see. If I just take one of the numbers and then present it as a float, we can see that the numbers we're dealing with are very, very small. So we need to change our actual change the actual vertices in our graph so that they can map on a little bit better. I'm sure there's a way of, well, I know there's a way, going back to algebra lessons by converting our various inputs. I need to go and look at it to actually work out what the actual equation is. It's been a while since I've actually done any of the SOHCAHTOA mathematics, the algebra from a while back. So, but you know, we can see that we can get something that resembles our input, and let me see. Well, there's something. There's an equation for working that out. We can see that we can get something that resembles what we want on the page, based off a graphics. The reason I put these as a loops is that for multiple graphics we can see, you know, these are two graphics on top of each other, and they come out as two graphics. So it's about getting both of those, by using a loop to kind of get both of those to then map on. Here, this make a bit more sense if I take off the lines. It'll automatically try and close them, but that won't appear in the actual output. I think that's kind of sort of enough for this session. Is there anything anyone wants to go over or quickly raise or ask? No?
No, not really. I mean, I had fun
I think
hanging out here today.
Yeah, I think we've kind of got enough. Thanks to everyone for your input, and Yoshi, thanks for showing that amazing patch and giving us a blast of all the microtonal piano. That was really great. Thanks for coming, and I'm not sure. I'll maybe wait a month before doing another kind of group session. I don't want to kind of run these. It's finding the right kind of time frame to run these. I sort of think a month is kind of long enough apart to not sicken everyone. But yeah, please, like, whatever patches you're working on, you know, please feel free to share. I like to kind of like upload these with a couple of the example patches. Yoshi, would you mind sharing your patch with me so I can kind of share it in a kind of
sure. I may clean up a
example?
bit. Yeah, I may clean up a bit before I can send it to you. But yeah, sure. Yeah.
So that'd be really handy. I'll put a link in the YouTube comments. Thanks very much for for all your help, and I'll hopefully see you guys all in maybe a month.
Sure.
Okay.
Thanks.
See you.
Bye.
See you next time.
Ciao.